an overview of biometric authentication on Android. My name is Michael Bailey. I'm a principal engineer at American Express. I work on our mobile apps there. You can find me on Twitter at YogurtEarl. We are hiring in London, New York, Phoenix, and a number of locations, so check out our website if you're interested to see what jobs we have open at any given time. Brief disclaimer, this is not security advice. I'm just talking about the platform. If you're going to use this for security in your application, talk to your InfoSec professionals and help them design a whole system that will use this as part of that system. So biometric Auth, what is it? Well, for a while it was just fingerprint. Fingerprint was all that Android offered as of Android 6. Up until 28, where they introduced a newer API that works with other types of biometric auth. So far, it's been iris authentication on some phones and face authentication, including the new Pixel 4 that just came out. So some things to note about biometric auth. What it is doing, usually you register somebody up front, and then later you basically are recognizing that that's that same person that you recognized before. You should note that multiple people can have their biometrics registered within one device and one user. So it might have 3 fingerprints registered, but they may be fingerprints from different people, depending on if they let somebody else put their fingerprint onto their phone. So just something to keep in mind as you're thinking through how you might use this in your application. So we're going to start with some of the older APIs, legacy APIs, although they only came in API 23, which a lot of applications still support older versions than API 23 still. So these APIs came around in 23 when they introduced the first fingerprint sensors. It's a fairly simple API. It comes with 3 main calls that you want to do on an API called Fingerprint Manager. If you're going to use this, you will have to put this permission in your manifest. It's a normal permission, not a dangerous permission, so you don't actually have to prompt for it, but it does need to be in your manifest. So the first thing you do is you want to get an instance of the Fingerprint Manager. You just call get system service. It gives you an instance of the Fingerprint Manager. If you're using the direct platform APIs, you're going to have to surround that with an API check because it's only on API 23 unless you're MNSTK 23 or higher, and then get that. Once you've got the Fingerprint Manager, the next thing you're going to do is check is the hardware detected. There are some phones, still new phones, especially low-end ones that have no fingerprint hardware, so it's important to check that that hardware is there. So after you get it, you would put that check into your flow. There's, in addition to low-end devices that don't have any fingerprint hardware, there's actually, if your user base has users who have older devices, there's a set of older devices where they had fingerprint sensors prior to API 23, like maybe they had a fingerprint sensor on 21. It didn't, then they had maybe their own API that did something with that fingerprint sensor. Some of those devices were then upgradable to API 23, but they will return false for is hardware detected because they don't actually work with these fingerprint APIs. But you may occasionally see complaints from people with these older devices saying, I have a fingerprint sensor and your app claims to have fingerprint support, but it doesn't work. There's not much you can do if you're really relying on that for security for those older devices. And those are going to be things like the S5, the Galaxy S5, and the Note 4. Originally running API 21 had fingerprint sensors, and when they got upgraded to API 23, they don't work with this Fingerprint Manager APIs. In addition to calling that is hardware detected, there's another way you can see if the fingerprint service is running on the device, and that's calling has system feature. Be careful when you're calling this. You probably don't need to ever call this directly, but it will return false on some API 23 devices that actually do have hardware, the fingerprint sensor, and they have a fingerprint sensor that will work just fine. So if you rely on this, you may be suppressing fingerprint for devices where it would work just fine. On newer APIs, this should return true, but for specifically some API 23 devices, this will return false even when there's a perfectly working fingerprint sensor. So just something to be aware of, and you shouldn't generally need to call that. So the next thing you're going to do after they're on a recent device, API 23 or newer, they have the hardware that's able to use the fingerprint manager, you're going to ask if they have enrolled devices. Obviously, some users haven't gone and configured their fingerprint sensor, so you want to make sure that they have the device, and if they don't, you may want to prompt them to say, go into your OS settings, set up the fingerprint, and then you can use it for whatever purpose in our app to make it more secure or easier to use, whatever you're using the fingerprint sensor for. So you can prompt them in that case. One thing to note is that this has enrolled fingerprints call on certain devices. On API 23, there are certain devices that have no fingerprint hardware, but if you call this, they will throw this exception. So if you're not careful and you call this and you haven't checked if the hardware exists, you may get this exception, which will crash your app on API 23 devices. So you generally always want to call is hardware detected first, and only if that's true, then call this, and that will protect you from those API 23 devices that didn't have fingerprint hardware, but will throw an exception when you call has enrolled fingerprints, when they should have just, obviously if they don't have the hardware, they don't have the fingerprints enrolled, and they should have just returned false, but that will happen on some devices, so something to be aware of there. So like I said, if they don't have the fingerprints, you can just tell them to go into the OS settings and add their fingerprints. In the case where they do have the fingerprints, this is where the real meat of the API happens, and it's this authenticate method. So when they do have it, you're going to call authenticate, and authenticate, what this does is it turns on the fingerprint sensor. It doesn't show any sort of UI. It just turns on the fingerprint sensor, and what it does is in general, you pass it a crypto object, and this is a wrapper around some sort of cryptography primitive that you're then going to use in whatever sort of security protocol or whatever you're trying to secure. You're going to use that object, and then as the fingerprint sensor goes through different events, either it read a fingerprint or it had some sort of problem or it didn't recognize a fingerprint, you're going to get a series of callbacks to the authentication callback that you passed in. But again, there's no UI, so on the fingerprint manager side, you're responsible for providing a UI that hooks into those callbacks and gives the user feedback about what is going on. This just turns on the fingerprint sensor. And if you don't provide a UI, they have no idea that they need to now put their finger on the fingerprint sensor. So you need to provide a UI. Attached to this. The one exception is for devices, newer devices that have in-screen fingerprint sensors. They have to provide some sort of UI, so you know where on the screen to put your finger. So they are going to overlay that, and there's really no way to know when you call this method whether or not it's one of these newer devices that has an in-screen. So I have a screenshot of it later, but you kind of get this awkward thing sometimes where you provided the UI because you have to, and then they overlaid it with something, so the user knew where to put their fingerprint. There's no library that you can necessarily use to pull in this, to provide this UI, but there is a sample. If you're using the fingerprint manager directly, there's some sample code that you can use if it works for your app at this repo on GitHub in the sample. Here's a few screenshots from that to see what it looks like. And this is just a dialog that they pop up, and then they take the callbacks from that authentication callback and they populate the dialog and go through the workflow to recognize the fingerprint or provide errors to the user. Here's an example of one of the newer devices that has an in-screen fingerprint reader. So you can see that you provide your own API UI, and then on top of that, they're going to overlay this thing with the fingerprint sensor, and you have to touch where the little fingerprint icon is. Looks a little awkward, but there's not much you can do here. So let's look at some of the things that you have to pass in to the authenticate method. You pass in what's called a cancellation signal. This is actually an API. Cancellation signal is an API that has existed since Android API 1. It's a very simple object. All you do is you create it, you pass it into the authenticate, and then you keep a reference to that object, and later you can call cancel on it. And it's your way of telling the fingerprint sensor to stop scanning. So if you had a cancel button in your dialog or however you have to cancel, you would call cancel on this. If the app goes into the background, the fingerprint manager is not lifecycle aware, so you need to say, your app goes in the background, you have to tell it, cancel the authentication. When it comes back into the foreground, you have to start the authentication again and prompt for the UI depending on what your workflow is. There's a flags parameter. The documentation just say set this to 0, so it was never used. There's a handler that you can provide. This tells it where your callbacks are going to happen. What thread are your callbacks going to happen on? By default, this can be null. By default, it's going to happen on the main thread, which may or may not be what you want, depending on what you're doing in there. You don't want to block the main thread, so you may want to move those callbacks onto a different thread, depending on what you're doing with them. There is at least one scenario where it can't contact the fingerprint service through IPC, where it doesn't respect this handler, and it will just call it back immediately on whatever thread you called authenticate from. So be aware that for most of the scenarios, except one scenario that only happens when there's some real problem contacting the fingerprint service running on the device, it will call back on your handler, but there is at least one flow where it just calls back immediately on the same thread and not on the handler. So crypto object, this is really the core of why you would want to use the biometric authentication APIs, is because you have some sort of cryptographic primitive based on either a secret key or a public-private key pair, and you want that to be secured unless the biometric authentication has succeeded, and then you can use it. So this passing in the right type of crypto object and setting that up right is really key to keeping the security throughout the whole solution and really tying anything to the biometric sensor. If you don't use the crypto object properly, then nothing is really tied to that biometric sensor, and it might prompt the UI, and they might touch their fingerprint, but it's not really securing anything. And this cryptographic object is actually just a wrapper around a number of other APIs that aren't Android specific: Signature, Cipher, and Mac. These are actually APIs that come from Java, so Signature is in java.security. The other two are in java.crypto. So these are objects that can be configured and used on just a regular JVM, which is nice for when you're writing unit tests and maybe you need to configure these or test these on a regular JVM. They're not Android specific, which is nice. Generally, the two that you end up using, depending on your use case, are going to be Signature and Cipher. Signature is generally used when you need to communicate to a server, like you're logging in or you're approving some transaction. That's generally when you're going to use the Signature. Cipher is usually used when you're encrypting something locally, and there's something locally on the device that you need to store. So those are general use cases, but again, you really got to think through the whole security protocol that you're using this for. So you've called authenticate, the fingerprint sensor is going, you've passed in your crypto object. Now you're going to start getting callbacks through these authentication callbacks. So the first one that we're going to talk about is on authentication error. And this one is a final callback, it's a terminal callback. Once you get this, according to the docs, it's going to be your final callback and the fingerprint sensor has turned off. You're going to get this callback for things like timeout. The fingerprint was just prompt on the screen, the user didn't do anything, and then eventually it'll time out. If too many attempts, like it's a finger that it's recognizing the finger, but it's like the wrong finger, it's just a finger that was never registered, it's eventually going to say too many attempts and it's going to turn off the fingerprint sensor. Or if they hit the cancel on your dialog, or you call cancel on that cancellation object, then you're going to get a callback here, authentication error. So this always means that the fingerprint sensor is no longer on, and if whatever flow you have needs to turn it back on, you're going to have to call authenticate again. This passes in an error code. and there's the API has a list of different error codes that tell you what it is. It also gives you a message which should be localized, so you can show it in the UI. So in this case, you can see here this too many attempts, try again later actually comes in that error string from this API, and you can show it in the UI, and it should be localized. There, again, one caveat to the rule of like this is always one call to this. There are the equivalent of this for some of the newer APIs we'll talk about in a few slides. On a Note 8 with the iris scanner, when you hit the cancel button, it actually gives you 2 callbacks. So you have to account for that, even though you usually only get one, and the documentation says you only get one. There's authentication help. So this gives you a message to show to the user, and that's generally all you're going to do with this callback. It's still scanning when it gives you this, but it's just giving you some text or some update to the user to help them get their fingerprint on there right. So if it moved too fast, if the sensor's dirty maybe, or if it just couldn't process it for whatever reason, it's going to say, please try again. So the fingerprint is still scanning, and this is just something for you to put in your UI. Authentication failed. This one is actually not terminal. It doesn't stop the fingerprint sensor when you get this, which can be a little bit misleading given the name of it. But this actually means that it recognized the fingerprint, it got a good read on the fingerprint, but it wasn't one of the enrolled fingerprints. So it keeps scanning for another fingerprint. Like maybe you forgot that you only enrolled your right hand and you touched your left finger. It's going to say fingerprint not recognized, but it's still scanning so that you can remember, oh yeah, I need to put this finger on the fingerprint sensor. So authentication failed is not terminal, and it keeps scanning. It doesn't provide a message. You actually have to provide a localized message for this one. There's no callback. There's no message to show to the user, so that's kind of left up to you in terms of what you're going to show there. And then the happy path is when you get authentication succeeded. So it is an enrolled fingerprint, it was recognized correctly, and now you're going to get this authentication result. Again, there's no message that it gives you to put in the UI. You have to provide your own. This is from the sample app that I showed earlier, fingerprint recognized. So it gives you an authentication result. An authentication result is simply just a wrapper around crypto object, and it's going to be the same crypto object that you passed in when you called authenticate, but now it is unlocked. So that same crypto object, if you had tried to use it to either do a signature or to decrypt something before, you would have gotten a user not authenticated exception because it wasn't unlocked yet. Now when you get this, you need to use it immediately. You can't kind of store it off the side and then use it in a background thread or something like that. It's only unlocked basically until that succeeded method returns, and then it's relocked up again. So you need to use this object immediately to decrypt something, which is why you may want to get that callback on a background thread. And again, the crypto object is a wrap, so the authentication result is just a wrapper around the crypto object. The crypto object is a wrapper around either signature, cipher, or MAC. And we'll talk a bit more later about how you create these objects to wrap with the crypto wrapper, or the crypto object. All right, so that was all the built-in platform APIs. That was Android.hardware comes on the device. There is Android X Fingerprint Manager compat. This is in the Android X core library. It's really a very simple wrapper with almost the exact same API on top of Fingerprint Manager, and really all it does for you is it does the API check for you. So you don't have to do an API check when you're calling the Fingerprint Manager because it basically just returns false, like there is no hardware here on anything before API 23. So you can skip the fingerprint or the API check when you're using Fingerprint Manager compat. So both of the things that I just talked about, they're all deprecated as of API 28. But some of you probably still have customers who may be on APIs that are older than 28, so it's still useful to know kind of what's available and what's going on underneath the covers, even on those older devices. And they even though they're deprecated, they still work on API 28 and 29, and presumably for some foreseeable future they will still work. They're just deprecated. So what came next? So they got deprecated in 28. Well, in 28, they added these biometric prompt APIs. Similar in some ways to the fingerprint manager APIs, but they came in 28. They don't even exist on any platform before 28. Similar structure. You still have this crypto object that you're passing in, and when it's succeeded, it's going to pass it back to you unlocked through an authentication callback. So a lot of the things I just talked about still apply to this new API. The structure is a little bit different. To get the biometric prompt through the built-in Android.hardware APIs, you create this builder, and you call build, and that gives you the biometric prompt. So you don't create it directly. There's no constructor in the built-in APIs. And then you use that, and you call authenticate on the biometric prompt that you just created. One minor difference is that instead of a handler to specify which thread your callback comes on, you pass in an executor. So a handler is a Android-specific construct that gives you a way to run post messages to a looper thread, which is all an Android very specific thing. Executor is a Java thing, so it's a little bit easier to test on JVM tests and use outside of an Android context as well. But similar type thing is it specifies the thread in which your callbacks are going to happen. All right, so the biggest difference here is that authenticate on biometric prompt actually gives you an API, a UI. And this UI is part of the system UI. It's not a dialogue inside of your app. This is actually system level UI coming on top of your app. And so you don't have to provide in biometric prompt your own UI. It gives you the UI for you, which can make things a lot easier than what you had to do with fingerprint manager. So in the builder, you specify the text. This is really all the control you have, so you have less control over what's going on with this new API. You basically get to specify these 4 things. What's the text for the button that will cancel the authentication, and then a title, a subtitle, and a description. And you pass those in before you start the authentication, and then the UI is managed. So it will change through the different states of not recognized or fingerprint dirty or too fast, and it manages all of that for you, and it localizes all that for you as well on the device. So in previous, when we talked about Fingerprint Manager, there's 2 things that you can check. Is hardware detected and has enrolled fingerprints? That sort of logic has now been rolled into a thing called Biometric Manager, which just has one call on it, basically, called can authenticate. And instead of returning a Boolean, it actually returns an integer. It's an intdef of biometric error, but one of the values that it, despite being called a biometric error, one of the values it returns is success. So maybe it would have been better called biometric result or something like that. But if you can authenticate, it can return the success integer there. The other things it can tell you is that there's no hardware, which is kind of similar to fingerprint is hardware detected, or it can tell you that there was none enrolled, meaning that there is hardware, but they haven't set it up yet and they haven't enrolled their biometrics. The downside to this API is this is only available on 29 plus. So biometric prompt came along in 28, but this API only came along in 29. So there's really not a good way in certain combinations of biometrics to actually check whether or not the user is really enrolled and set up for biometrics. So some devices, like the Note 8, have 3 different biometric authentications. They have fingerprint, they have iris, they have face auth, and I don't know that there's even an update available to API 29 yet. So on API 28, there's no good way to know that other than just falling back to the fingerprint manager that calls is enrolled, and which only tells you about fingerprints. There's no way to tell if they don't have fingerprints enrolled, but they do have iris or face authentication enrolled. There's just really no consistent way to tell that on API 28. So that's kind of a hole. So the best bet is just to look if they have fingerprints enrolled and use that as kind of a proxy for can authenticate. So if they only had iris enrolled, there's really no way to detect that. So what does it look like when you would call this API? And again, this is the Android.hardware API built into the platform, only available on 28 and above. If you want to use the can authenticate, it's 29 and above, which is Q. So you would check for Q, you would get the system service, call can authenticate, it returns an integer. You'd use a when statement to perform different actions based on the result. If there's no hardware or the hardware is unavailable, meaning it can't contact the service running on the phone, you can just suppress whatever flow you have in your app for biometrics. If the user it says none enrolled, then now on 28 plus, there's actually an intent that you can start directly to send them, rather than giving them just text that says, hey, go to your settings, you can actually just fire off an intent or tell them, hey, click here to go set them up, and then take them directly to kind of deep linked into the settings to set up their fingerprints with this action enroll. The action fingerprint enroll is only available on 28 and above. If it's successful, you build this biometric prompt, you put in the strings that you want, and then you call .authenticate on that. So there's some challenges, as we've talked about. Fingerprint Manager, it's API 23 plus, but it doesn't provide a UI. You have to provide your own UI. It's not going to work with Iris or Face Auth, which most devices up until Pixel 4 have had Face Auth and Iris Auth in addition to fingerprint. Pixel 4 only has Face Auth. So if you only use the old APIs, then you basically don't support any biometric auth on the Pixel 4. So that's a good reason to consider using biometric prompt. Downside of that is it's API 28 only, and it's not a direct replacement for the Fingerprint Manager APIs, specifically because this authenticate method, which kind of does the same thing, except it prompts this system level UI, where if you're calling the old one, you have to provide your old UI. And then there's the can authenticate problem, which is only 29 plus. But thankfully, they are working on an Android X biometric library that kind of solves some of these problems and works around a lot of these things. They just released RC2 yesterday. So that sounds like it's getting close to a 1.0, but there is currently no stable release, but hopefully a close to stable release. This works around most issues. It's lifecycle aware, and we'll go through a couple kind of things that it does. One of the things that it does, and they just added this in the RC2 build, is for certain types of authentication on certain phones, like the Face Auth on certain Samsung phones, that authentication doesn't really work to unlock a crypto object with the biometric prompt APIs. You're going to get an error callback, basically, or it's going to throw an exception. And there's no way to know when it says can authenticate. That just means that there's some biometric setup. You don't know when you call authenticate, is it going to prompt for iris? Is it going to prompt for fingerprint? Is it going to prompt for Face Auth? So you might call can authenticate, and if the user goes in and selects Face Auth as their preferred biometric, it's going to prompt them for Face Auth, give you the callback only to have an error, and it's not actually going to work. So that can lead to some really awkward scenarios. So what they've done in Android X Biometric is they basically have a blacklist of devices that this is a problem with, and they basically fall back to Fingerprint Manager on these API 28 devices, because there's really nothing better to do. So there's a blacklist for certain list of devices, and you can kind of go look at the source if you're curious which devices those are. But the good thing is that this is an Android X library, so it'll be updated over time, and they're working through a lot of these issues so that you don't have to worry about all these variations across APIs and across the different quirks that you get with different devices. So the biometric, Android X biometric API, the good thing is it's all the way back to API 14, I believe. So you can just call these APIs, no API checks. The API is similar to the biometric prompt API, but it actually works a little bit differently. You call biometric.from. You don't get it as a system service. You call biometric.from context, and you can get this on any API. You can get biometric manager. You call can authenticate. Again, you can call this on any API back to 14. What it does on 28, given that there is no actual can authenticate on 28, it basically does the same fallback it does from before, and it just calls Fingerprint Manager. So this is not going to work if they only have iris and authentication set up. It's just going to say there is no biometric set up on this device. It's going to say it's going to return not enrolled, because it's basically what it's doing underneath the covers is just checking the Fingerprint Manager on 28 and below, because there is no biometric manager, can't authenticate until API 29. Instead of building the biometric prompt using a builder, now they have this additional kind of intermediate object called a prompt info, which basically has the same set of information for the title and other things. You put that in there, and then you take that prompt info and you're going to pass it into authenticate later. But to get the biometric prompt, you now call a constructor on biometric prompt for the Android X version. You have to pass it in a fragment activity, because what biometric prompt in the Android X version is doing, and how it kind of masks this across all the APIs, is that for 28 and above, when it shows the authentication dialog, it is showing the system UI. But then it has a very equivalent, a very similar UI that it's providing as part of their library for older versions. So with Fingerprint Manager, you had to wire up your own UI and handle the lifecycle and all that. With this one, you just call this one API, and they kind of emulate this UI that you might get otherwise. They include localized strings for a lot of locales in the Android X library, so you don't have to worry about managing that, where that was kind of an issue that you had to deal with Fingerprint Manager. But you have to pass in the fragment activity, because as part of that, on those older APIs, they actually show a fragment, which is part of your process, kind of emulating what you get with a system UI on newer APIs. So then you call authenticate. You pass in the authentication callback into the biometric prompt constructor. Authenticate sort of works the same, except it doesn't take as many parameters. You just pass in the prompt info, which has the UI strings that you want to display. So those ones that you're controlling, you will need to internationalize those ones. But the other things like fingerprint recognized and the things that are coming from the sensor itself, they've internationalized those ones for you. Then there's the crypto object that you pass in. This is the crypto object that is going to get unlocked if the fingerprint or the biometric auth is successful. They don't expose the authentication help callback, because you were not building your own UI, and that was the main purpose of it. It actually, I think it is exposed if you call the biometric prompt APIs directly, the ones that are part of the platform. The Android X version kind of hides that callback. You could maybe say it's useful for logging or things like that to see what's going on if you wanted to log those, but you're not really going to show them to the user because they provide that. But just to be aware that on the Android X version, you don't get that authentication on authentication help callback. So just to give you an idea of what the different UIs look like, the one on API 23 is their kind of emulation of the system prompt. You can see you pass in those same set of strings. It's a little bit different. One is less justified. The system one, at least the AOSP one, is centered. The system level one is customizable by OEMs. So this is what it looks like on AOSP. This is going to look like on a Pixel for fingerprint, like on a Pixel 3. For different OEMs, this may look slightly different. Because it's a system level UI, it's not part of your app on API 28 and above. Just to give you an idea of what a user can do on devices like Note 8 that have many different options, they can choose face recognition. They may or may not set that up. They can set up irises. They can set up fingerprints. And then they go and choose which one they want to be the preferred one. And that is when you call biometric.authenticate, it's going to prompt up that, whatever the user has set in their setting. And again, on 28, if they haven't registered any fingerprints, but they have registered irises, in theory, the irises would work if you had some way to know that they had set it up, but there's really no way to know. So you're just going to basically fall back to saying there's no biometrics if they only have irises set up. And then the face recognition on Note 8 doesn't really work at all. So that's why they're kind of have this blacklist to fall back just to fingerprint for devices like this on API 28. Just to give you an idea of what OEM level UIs might look like, these are the APIs from Samsung. So this is the iris Auth. You have to like line up your eyes, and it tries to scan your irises, and it's at the top of the screen when you pop that up. But again, it has title, subtitle, description, and then negative button is, you probably put cancel in there or some localized version of that. If it's a fingerprint and it's on the back of the device, then you kind of get that middle screenshot there popping up. If it is in the screen, you're going to get this overlay, and that the icon there is where you actually have to put your finger. Different OEMs may do this differently, so you can't really rely on where this overlay is going to be on your UI. You just have to kind of assume that it's putting something on top of your UI, and the user's going to know what to do because you gave it the right strings to put in there with the description and the title and the subtitle. These APIs, you probably don't need to call these, but just for sake of completeness, I thought I'd mention them. On 24 and above, you can detect whether the fingerprint is running, although you should just call it has hardware. On newer versions, on 29, you can actually see whether there's iris hardware or face hardware, but there's no way to tell what the user selected as their preference or what the user has enrolled in out of all those. So you can tell that it's there on the phone, which is not entirely useful, but I thought I'd mention it because you might think of a use for it. All right, so back to this crypto object thing that I kind of glossed over a little bit at the beginning, because this is really the heart of why you're even doing this biometric auth, is you set up this crypto object, and it can't be accessed, and you can't use it unless the biometric auth succeeds. So let's talk a little bit more about that. Again, the cipher is generally used for local stuff, and the signature would be used for communicating with your server authentication. But it really, how you set this up is really going to be very specific to your application, what APIs you're doing, and what you're trying to do with this. So I'm just going to go over some of the key parts that will be common across different things, but talk to your InfoSec people about exactly what the right parameters are to set here. And in Kotlin, in Java, you would have a huge catch block here because these APIs throw a bunch of different types of checked exceptions. Kotlin doesn't make you catch checked exceptions, so going and reading these different APIs that you're using to set up these cipher objects, you're going to want to catch some of these exceptions because they will happen. You want to make sure you have good crash reporting because some of them can happen in certain scenarios, and you may not be able to reproduce those, so you want to have good crash reporting around these APIs. So Android key store, this is just like a hard-coded string, like a literal string that you have to put in. This gets you access to the Android key store, which is a system-level API. So this is just the string that everybody has to use when you're getting an instance of the key generator or of the key store. This is a name that you give to the object that you're creating, to the key that you're creating, so that you can go back later and look this up and use it. So this first flow that I'm showing you is how you create the key, and then later, once the key is created, it's sitting in the Android key store, you're going to go back and look up this key, after your process has died and your process gets recreated, and you now want to use this key that was already generated. You're going to have to know this same name and pass this in to go and get access to this key in the future. So you can name it whatever is appropriate for your application. This is probably the most important line out of all these slides, is to set user authentication required equals true. If you don't set this, then really nothing at all is tied to your biometrics. It's just like a bunch of APIs that you're calling, and you might get a callback that tells something happened with the sensor, but if you don't call this, the object's already unlocked regardless of your biometrics. So calling the authenticate thing didn't unlock anything if you didn't set this to true. So if there's one thing you take away, is that you need to set user authentication required equals true and use the crypto object, and then base all your security on that. This one is an API 24+. For some use cases, you're probably going to want it. What this does, the set invalidated biometric enrollment. If, when you initially generate your key, let's say there's 2 fingerprints on the phone, somebody later goes and adds a 3rd fingerprint. For certain use cases, you don't want that third fingerprint to be able to unlock whatever was done and registered previously. So this will wipe out that key and make it no longer valid. You'll have to regenerate a key because a new fingerprint was added, or the face authentication was changed, or the iris authentication was changed. So depending on your flow, and if it makes sense to just let them continue to use biometrics when somebody went in and added a new fingerprint, then maybe you can set that to false. But if that doesn't make sense, then you definitely want to set this to true. Then you call generate key. So what this does is it puts a key into the Android key store for later use. And so it's ready to go. It's there. It can't be used until you have biometrics and you call authenticate and wrap it into crypto object. Let's see. So crypto object, how do you get one of those? So you get an instance of the Android key store. You give it the name of the key that you're trying to get a hold of. You go and you get the key with calling get key. You then wrap that key in a cipher if you're using cipher. Similar API calls for signature. You get a cipher. Then you take that cipher and you wrap it in a crypto object. And then you use that crypto object to pass into authenticate. And then only if you set user authentication equals true, only when you get that authentication succeeded callback, then you can use the crypto object that's there. Otherwise, it's locked up. And again, that's really the whole crux of using biometric authentication. Use the crypto object. Make sure you set user authentication equals true when you create the key. As one more level of kind of security that may or may not make sense for your authentication, let's say you are using this for some sort of server interaction, authenticating with the server, a login, or transaction authentication. You may want to prove to your server that the key that you're interacting with is locked behind biometrics, and how it's stored on the device. And there's a bunch of other things that you can prove about the circumstances in which this key was generated and what key you're using. So I don't have time to go over this, but there's documentation about how to use key attestation. I think that links to, there's also on the Google samples, there's a sample of how to verify the key attestation on your server side. But the two kind of main things that you may be interested in is that you can prove to your server or whoever else needs to verify this, where is it stored? Is it stored in software, which on lower end devices it is. It may be easier to extract the key, or other things that may be less secure. It's stored in software, trusted environment, which is more secure. It's based on some hardware things, and then Strongbox, which is kind of the best. You get that in Pixel 3, Pixel 4, have Strongbox. So that's where the key is stored, how secure is the key on the device. And then user authentication type. So this allows you to prove to your server that this key is actually tied to biometrics, which may be interesting depending on what you're using the key for. Just a few last things. File bugs, please. If you use Android X Biometric and you find a bug on a specific device, file it, give as much information as you can, because if they put a fix into Android X Biometric, we all benefit. And we may not all have that same device to test on. We may not realize that device has this weird flow through the biometric APIs. And so if they can work around it somehow in Android X Biometric, file that bug so that we can all benefit from that. And there's a specific component on the bug tracker for this. Documentation for this stuff is a little spread out and hard to find. These are the best ones that I recommend. One is a blog post from 2015. It's still one of the best references. There is a fingerprint manager sample code, which is useful. Again, that uses the old APIs, not the new ones. And then for biometric prompt, the new Android X stuff, there's a demo application in the Android X source tree on AOSP, and the link is there. There is a training document on developer.android. They show their example doesn't use the crypto object, which is not, I wouldn't recommend doing it the way they show it in that thing. So there's some good information on there, but just be a little bit wary about the example that they give on there. So important takeaways. Use Android X Biometric. Always use the crypto object and set user authentication equals true. And then consult with your InfoSec professionals about the end-to-end security flow that you're using this as part of. And thank you.